What we're going to be looking at is how to detect if something is an acid or an alkali. Now, the chemicals we use for detecting acidity are known as indicators because they indicate what pH a chemical is. Now, you could use an indicator such as universal indicator, and that gives you a broad range of pHs from 0 to 14. But what we're focusing on for now is a simple indicator known as litmus. Now, litmus is a chemical which is either red or blue. When it's blue, it means it has been in an alkali. When it's red, it means it's been in an acid. Now, there is one caveat to that. If you put it in something neutral, it doesn't change colour at all. And you're going to see that when we test a neutral substance from the ones arranged in front of us. But as you can see, we've got many chemicals: bleach, water, hydrochloric acid, sodium hydroxide, lemon juice, soap and vinegar. We're going to start by looking at the hydrochloric acid. Now, the hydrochloric acid is in a dropper bottle, so I'm just going to take this and pop it into this first dip in my spotting tile. Spotting tile has got 12 dips there so that we can test up to 12 different chemicals. So we have some hydrochloric acid there. Now, we're just going to use this to check what happens when an acid is subjected to red and blue litmus paper. I'm going to start with the red. When I dip this into the hydrochloric acid, you should see that it is still red. Okay, so we said earlier, red means acid. Well, let's make sure it is an acid by taking some blue litmus. I'm going to pop that in and see what happens to it. As you can see, the blue litmus has turned red. This proves that the hydrochloric acid is an acid. Now, next we're going to do sodium hydroxide. Sodium hydroxide is a relatively strong alkali. We're just going to use this to, again, make sure that our litmus paper is working. There's no trickery going on here. So again, a few drops into my spotting tile, and we're going to first add the blue litmus. So, blue litmus stays blue in alkalis. Red litmus, there it is, turns blue in alkali. So what we now know is if you place red litmus into acid, it stays red. Blue litmus into acid will turn red. We also now know that blue litmus in alkali stays blue, and red litmus in alkali turns blue. So litmus is an indicator for whether you are acid or alkali. If you're acid, it will always be red. If you're alkali, it will always be blue. Let's check some of our other chemicals. Lemon juice. Let's find out, is lemon juice an acid or an alkali? Once again, I'm going to be testing it with both blue and red litmus. So there's my blue litmus, and here's my red litmus. We'll start with red litmus, so let's see what happens. Absolutely nothing. Stays red. Blue litmus, you can see it's turning red. That proves that lemon juice must contain an acid. And it does, it's got citric acid, also known as vitamin C. Now let's try some vinegar. I'll pop some in my spotting tile, a few drops, and then we'll add our red litmus. I've got a piece here prepared. You see it stays red. Blue litmus turns red, proving vinegar is an acid. In fact, its common name is acetic acid, but also known as ethanoic acid. Now next, we're going to use soap. Here it is. Once again, a couple of drops in our spotting tile. I'll put a couple here. 1, 2, 3 drops. And once again, we're going to add blue and red litmus. So let's start with our red litmus first. In it goes. And if you look, it's slowly turning blue. Let's check with the blue litmus as well, just to be sure. And the blue litmus is staying blue. So you could see that was slightly changing blue. Over time, it's gone a purpley shade. That's showing us that the soap is slightly alkaline. And finally, we have water. A few drops in there. And once again, we're going to test it with both our red and blue litmus. So we'll start off with red. Here we go. That's a little bit of red there. Pop it in. Oh my, it stayed red. That must mean it's an acid. Let's make sure. Drop it in there. Oh my, it stayed blue. What does this mean? Well, water is actually a neutral substance. What that means is it's neither acid or alkali. So if you start with red litmus paper, it will stay red because there's no alkali there to turn it blue. If you start with blue litmus, it will stay blue because there's no acid to turn it red. So when we're using litmus paper, we usually have to use both pieces of paper at the same time because you need to make sure that the color of the paper does not change. If the color of the paper will change, that shows you that it is either acid or alkali. If blue turns red, it's acid. If red turns blue, it's alkali. You don't just look at what color the paper is in the chemical. So as you can see, we have 1, 2, 3 acids, we have 1, 2 alkalis, and 1 neutral substance. And that neutral substance is water.